everybody in India probably already knows about the Big Billion Day sale that Flipkart does every year, which is akin to the Cyber Monday or let's say Black Friday sales that happen globally. And if you're curious to know about how the infrastructure behind it looks like, how is it run, how is it built to scale, we have our special guest today, Vaidyanathan, who is the senior engineering manager from Flipkart, from the platform team of Flipkart. And we're going to talk to him about the infrastructure behind it, how it has been built, and we're going to try and get some insights, around that as well. So welcome, Vaidyanathan, to our show.
Hi, Gaurav. Very happy to be here.
Yeah. So let me start with this question, right? So I'm a corporate trainer and I teach about cloud. And this week, I got a question about when I was talking about how you design and build things on scale and scalability, high availability, fault tolerance, and so on. The question that I got was about, hey, how it is done in production and how, let's say, someone like Hotstar does it and how Flipkart does it, especially in the context of Big Billion Days. So that's when I think you are the perfect person who could throw some light on that. So I'm really curious to know how this infrastructure is built to scale and how you guys do it behind the scenes.
I think foremost, I've been very lucky, I would say, to have witnessed every single Big Billion Day that's happened so far. So it's about 11 Big Billion Days. The very first Big Billion Day started when I just joined the company, and
was it around, I think, 2013?
2014.
Wow.
It was the very first sale. As one would expect, things were breaking all over the place, right? And that was the day I sort of also wrote an article sometime later that when I saw the first Big Billion Day, I was reminded, or I had immediate respect, you could say, for the IRCTC website.
Right.
When the kind of scale hits you, things that can break all over the place, right? So I had newfound respect for IRCTC, and of course, subsequently, all of the Big Billion Days started getting more stable, each and every season. So, but yeah, that was the first introduction to Big Billion Day. And yes, on your second question about the slide that you showed, and all of that is public information. So it's not like I'm probably going to talk about something that's confidential information. This is a blog that my team here in Flipkart, it actually, all of my team writes a lot of technical articles here. This one published by Animesh Agarwal from my team. And this is about 23, if I'm not wrong. Yeah, this is 23. The current data, of course, I can't reveal those numbers, and even the X, how much it is, BIU versus BBD. I probably can't comment on all of those things. But yes, you got the overall story right. Flipkart has a very big difference with respect to its BAU versus BBD. BAU is business as usual, and BBD is a Big Billion Day. And this very challenge, in fact, is the ground for the kind of infrastructure and the investments that we did over the last couple of years into bringing full stability into this picture with these kind of constraints and getting it. So yeah, happy to talk more about that.
Sure. How does the infrastructure behind it looks like, right? Because when you imagine that like 6x, 7x kind of a scale than the normal business as usual, which is, and then Big Billion Day, when you get that kind of a traffic, the first thing that comes to my mind is which cloud, how it is structured, and do you use how do you prep your systems? Like, is there like a lot of auto scaling? And let's maybe start with the cloud infrastructure that you may be using.
All right. So maybe some people might know it because if people do read our blogs, this might be not come as a surprise to many, but Flipkart has its own cloud, and we call that as the FCP, or the Flipkart Cloud Platform. And we have been invested in this whole cloud journey, our own on-prem kind of a setup from multiple years now. It's probably more than 9 years, possibly. We have data centers across the country, and the entire life cycle of data center and building things on top of that is something that happens. And this is sort of the secret sauce, you could say. And
indeed, because most organizations that I've seen, they start with cloud and then they move to, at some point of time when they grow to a certain scale, they kind of move to their own data center. That's what has been trend. But in this case, we see that, is it all running on your own data center so far, all the Big Billion Days included?
So I would say most of the big billion days were running on our on-prem data centers. But then the recent ones, it's been about, I would say, 2 to 3 years since we have been in this hybrid cloud kind of a way. Hybrid cloud, for hybrid cloud, we basically use our on-prem as well as GCP. We are tied up with GCP. And that sort of what makes the whole scale out or bursting out into the public cloud more easier for us.
Exactly. You have your own data centers, and to burst out in cases like big billion days where you may not have exactly predictable kind of a traffic, you are kind of bursting out to the cloud. And that in that case, we are talking about Google Cloud.
Yep,
in this
the
case.
Google Cloud. So the whole bursting out into public cloud, or this is typically called as the hybrid cloud setup, right? As you're probably aware, it gives us a lot of benefits, right? And those benefits are mainly around cost, right? The reason why I say cost is essentially we don't have to, buy hardware for BBD and sort of pay for it through the entire year.
Exactly.
The utilization is never going to be that much. Like you also said, it's some X of BAU, right? So the hardware typically fully gets utilized during BBD, and we don't want to pay for that same hardware to the rest of the year. So the hybrid sort of helps achieve that part of the goal.
I think you have the predictions for the rest of the year where you are using your own existing data center, and for bursting out, it's few times X, plus it is also for a short amount of time.
Yes.
And for that, I think this kind of becomes like an optimal setup. And then you can just turn it on anytime, scale it to any level that you want. And then it happens during the big billion day, I believe.
Absolutely. So the whole public cloud, or I'm sorry, the hybrid cloud, it also gives us not just the cost advantage, but it also gives us advantages from a reliability perspective. Reliability perspective as in, okay, if one cloud goes down, potentially there's still one more cloud which can, sort of save the day. It also gives us advantages from a flexibility perspective. We have a lot of flexibility in sort of telling, okay, this kind of workload, I want to run it on-prem, and maybe a different kind of workload, I probably want to run it on the public cloud.
Yeah, especially when you want to run some experiments,
Yes,
maybe some sort of chaos engineering stuff just to test your resilience and all of that. Maybe you can use both the clouds and have that. Awesome. So what also that means is, since your journey started from the private cloud kind of infrastructure, so is it like a self-service platform that you have built for the private cloud, and how would it work? Because I can imagine people starting with public cloud mainly also for the reason that you get a lot of managed services, and it is in general easier to use, let's say, databases and load balancers and auto scaling features and those kind of things, right? So how is it done? How would it work with this private and public hybrid cloud mixture, where you are running some on premise or in your data center and some on cloud? So how about managed services? Does that mean you're not using managed services, or you're using managed services in public cloud and then have some other way the things are done in your private?
Great question, right? So in Flipkart, we, like I said, we have something called as FCP. FCP is a cloud platform. So we have been investing in the whole cloud platform for quite some time. Initially, maybe you could start off when we started off many years ago, maybe 8 years ago, 7, 8 years ago. It was largely bare metals that were assigned to multiple teams, right? But then subsequently, we started that cloudification process where people could basically request for any virtual machine at any point in time. They could, and you could just spawn up automatically and all of that. So since we have been invested in that, we also thought, apart from the IaaS construct, which is instance as service, we also want to probably start building managed services on top of it, which sort of led to the whole databases as a managed databases and all of that started sort of coming on top of that. We also have Kubernetes as a service. So those kind of services, which are typically expected from most clouds, are sort of built there. Your other question about whether do you use public managed offerings? I think the public cloud sort of just came in about 2.5 years back, like I said. So previous to that, of course, we were not using any of that. And naturally, one of the main reasons is I think managed services typically cost quite a bit. That's one of the main reasons why we felt in-house, sort of building some of these managed services made more sense to us.
All right. So you have built the platform on top of which all of this is running. So basically the entire FCP, when we talk about, it is a cloud platform. So it converts the bare metal systems into self-service kind of an infrastructure. And on top of that, you have your own kind of managed platform.
That's right.
So does that involve,
yeah, good.
does that Kubernetes today, or how is it, and how does it work really?
Absolutely. So I think when you're talking about this whole hybrid cloud and we're bringing the whole managed thing, right? Managed is really important because when things go down, you want something to be automatically managing that. It's a lot of pain. I mean, that's the reason why most people today use managed. Now, when we're trying to, tie this whole on-prem cloud with the public cloud and then sort of have some sort of management where you can also burst out into it and that seamlessness of thinking about it, it sort of gets very difficult if one side of the world is unmanaged and the other side is cloud managed kind of a thing, right? And one of the things that what we did at Flipkart at least is we ensured that the same service is sort of running in both the places, so that abstraction becomes far more easier. And GCP is largely just one more region for us, and we are not really using GCP's own managed services, but it's still Flipkart owned managed services, just that the GCP's infra is being used, and that infra, of course, could be in both ways, like we're talking about. It could either be virtual machines or it could also be Kubernetes pods and all of that.
Right. And does that mean including your auto scaling of the nodes and everything is kind of, so you probably are using the auto scaling feature of the Google Cloud. And on top of that, you have your own layer of Kubernetes engine, which kind of creates this unified structure. Is that correct thing to say?
So that depends how we have implemented it. But what I'm trying to say is the managed services that we have built in Flipkart will still be the abstraction for most of the, all of the engineers in Flipkart, right? All the architects, people who are using FCP, they will still be using Flipkart's services. Underneath
It's a
that,
unified.
yes, unified. Underneath that, like you're saying, it could very well be possible. It will be using GCP's infra, services underneath it, so that the experience is still consistent.
Right. And it's basically, it's just another data center for you, Google Cloud is,
Yes,
and you're treating as more like a, the burstable data center.
absolutely.
Where you can just get more infrastructure, and you're relying on infrastructure as a services. And on top of that, your platform still exists, and that's kind of Kubernetes helps you to create that unified
Yes.
platform, at least partially.
At least partially, yes. So the Kubernetes move itself, I think we started about again maybe 3 years back, 3.5, 4 years back, perhaps. So when that Kubernetes move, and Kubernetes was sort of the basic requirement, right, before we start sort of thinking about the whole hybrid cloud and all of that, because it's really the glue which connects the whole, makes the whole hybrid thing more easier. And as part of the CNCF and, Kubernetes has been really important in the whole CNCF project, and all of that. That story,
Kubernetes
right?
is the central, and we have the entire ecosystem revolving around it. Is how I see it.
Absolutely, absolutely. So we sort of first invested in Kubernetes. The whole investing into Kubernetes, by that I mean, first of course going in fully with the whole stateless, and then also started moving our stateful workloads into Kubernetes. So
That's interesting, because when people start using Kubernetes and when initially came in, it was very easy to move the stateless infrastructure to Kubernetes because it was designed for that. But when you say stateless, does that also mean databases? Are you moving or running databases on Kubernetes too?
yeah, so stateless typically means applications, and like you rightly mentioned, a lot of people I think typically move their applications there, and it's easy to burst it out as well, because you just new pods just keep coming up and it's really easy to burst. But then services alone, applications alone are not enough to really scale up a service. Most of the time the bottleneck is in the database layer, right? And that's
Exactly.
not able to scale up, it's a big problem. So the database part we typically call it stateful. I think stateful is anything, if you, from a Kubernetes perspective, if you talk about it, it's largely um, pods that have some sort of state associated with that. So stateful is one.
It can be application, it can be databases, but databases are inherently what we call as stateful, right? And I think Kubernetes at some point of time had this, I mean, we already had that concept of pet versus cattle. And when Kubernetes came in, instead of treating our servers as pets, and I can closely relate to it because when I was part of the ops team, we spent a lot of time just naming our servers. We were attached to them. So we were treating them as pets, really, right? And then Kubernetes changed the world, and then it was just unnamed servers, and it gave a lot of advantages. But a lot of companies still use the databases, and especially the databases part. When it comes to relational databases, we are still treating them as pets because it's tied to one node, has the state, has some information which is specific to that node as well, right? And when that happens, how And most companies are afraid of running, especially their databases on Kubernetes. So how does Flipkart do it? And are you using Kubernetes also for databases, or is that because you also mentioned that you're not using managed services, right, from Google? So how do you run the databases is something I'm really curious to know.
So at Flipkart, we run TiDB. TiDB is one of the upcoming and horizontally scalable SQL wire format data store. It's actually SQL format at the top, but underneath it's a key value database, right? And it scales beautifully well. So that is something that we run on Kubernetes for all our, you could say, monster SQL workloads, which are like really big, which kind of need that kind of seamless scaling and all of that. The second thing that we run is HBase. So we run HBase on Kubernetes. As far as you know, very, very few people probably do that today, but we are one of the earliest people in that getting that HBase on Kubernetes. So that's the second thing that we do. The third thing we do is Aerospike. Aerospike also runs on Kubernetes. And the fourth thing is there is very active development that we're doing in order to get the MySQL world also onto Kubernetes. So of this, the TiDB operator is the open source operator that it's available on TiDB.
All right.
Aerospike
So
is
you're
also available.
essentially what you mean to say. First question I have, sorry to pause you there. So when you say TiDB or the Titanium DB we're talking about, so can we say that it's like a MySQL replacement created for cloud or cloud native?
Yep, absolutely. I think you could say that to a very reasonable extent, right? Because like every DBRE work is solved probably knows that scaling databases is typically hard and there are limits to it. That limit, it gets a little bit difficult to go beyond that. So in Flipkart also, for example, our virtual machines sort of top off at around 3.5 TB sort of a thing. It doesn't go beyond that. So when business increases and, data increases because of all of that, and we're catering to multiple services across the company, right? This horizontal kind of scale out becomes very hard to scale out, scale up, or scale out, whatever you call it, right? Like, I mean, both of them, scale up is different, scale out is different. Both of that becomes very important. And TiDB has been pretty successful for us. It's able to sort of manage that massive kind of both the data perspective as well as from an availability perspective. It's actually able to give us what we need.
So let's say if I have a MySQL database right now, is it prudent to say that I should, if I want to scale it and build it to scale, can I consider TiDB as a replacement for MySQL? Or is there any consideration there where I may want to still continue using MySQL instead?
So in Flipkart again, right? Like a lot of the systems were using MySQL, and it's largely a MySQL as far as supply chain and all of that is concerned. We heavily use MySQL. So one of our primary motivations was to ensure that we don't ask all of the teams to go and change their, code, right? Application code, refactor them completely to talk to a different kind of maybe Postgres or I don't know, something else, right? So we didn't want to do that. So the objective was very clear that the wire format is absolutely important. So the drop-in replacement factor that you brought about was really important for us. And so we said that, and the answer to your question is yes, that's largely what it means. Apart from a few nuances here and there, maybe some queries are a little bit slow here, perhaps, right? But and maybe some of the things don't work exactly as MySQL works, but you could say 99 point. It's about 99 things work out.
I think for most organizations, it would make sense because when you say some queries and certain issues, we are talking about the petabyte scale that Flipkart operates at. So majority of the organization, if they're trying to consider using MySQL and not having to change their code base, TiDB could be kind of an in-place replacement for that.
Correct. There are, of course, other containers also. There's Cockroach, there's Yuga, Byte, and perhaps newer ones keep coming every now and then, right? But like I said, I think those are not, I don't think they are MySQL compliant or sort. TiDB was specifically MySQL compliant. I think they identified that niche very well, and
that's great. You also, I think you at some point of time mentioned about the operators, right? So I assume that since you are not using a managed service, like the managed databases service on cloud, is that where operators come and help you? How are you using operators and for what purposes at Flipkart? Especially in the context of databases that you started mentioning about when I paused you. So can we elaborate a little bit on that?
Absolutely. We are in, end of January, and 2 weeks back, operator would have just meant, the one that which I'm talking about.
The operator is the one from the GPT, I think.
Absolutely. Now, when you
Yeah,
Google for operator, it says OpenAI, what are the
absolutely.
operators and ability to do a lot of things. So, yes,
Mhm.
so we are not talking about that operator. Just for your audience to be very clear, we are talking about a different kind of operator. We're talking
We're
about a
talking about the Kubernetes
Kubernetes
operator here.
operator. Yes,
Yes,
Kubernetes
correct.
operator. So, Kubernetes operator is actually the magic sauce that, again, a secret sauce, you could say, that makes this whole databases on Kubernetes a bit more easier, because unlike stateless applications, when you start attaching Discord there are far more things that are nuanced with databases. It could be, I don't know, like, sharding, or, recreating that, having much more deeper health checks, or copying data from one point to another, and various other things which typically come with databases, which don't come with, just an application with some sort of disk, or stateless applications for that matter.
Absolutely.
And Kubernetes can't solve for all of straightforward, right? It can't do that, but it has tools. If you leverage those tools and build your logic around that, extend those tools, rather, if I were to say, um, that whole thing is called an operator in some way, right? An operator is almost like I like to think of it more like a robotic operations engineer for sort, right? Who's sort of really well skilled at Kubernetes, as well as knows in depth of databases and how to manage them and administer them and all of that. So that's what largely an operator does for us.
The operator is more like without using the models, traditional models, it's something else that you write as an extension for Kubernetes, where it's probably based on certain rules that it looks at. And it's basically a rule-based manager of sorts, which is looking at the events
Yes.
and then taking certain action based on that. And what kind of actions are we talking about when it comes to operator? And especially in the context of databases, when you say, what kind of activities it can do, basically?
Yep. And to answer that question again, right? Like you said, it's not AI and it's largely rules. What kind of rules again? That if you double click, just like how Kubernetes has that event loop and says that, oh, I'm going to get it to kind of, I have an ideal state to reach to, and this is how I'm going to reach to that ideal state from what the current state is. Very similarly, operators also use custom resources, and you sort of define what is it that you want the operator to do. So when you ask what kind of things it does, it's up to us to sort of define that. Okay, this is an operator for taking a backup. So the job of this guy is to take a backup or to probably restore it, and stuff like that. So when you give it that kind of work to do, it again gets to work. It starts interacting with Kubernetes and extends that, starts looking at these custom resources, and if anything changes there, it sort of gets control again, makes those changes, whatever you're coding that part, right? So it's sort of, you're extending that whole Kubernetes framework to tap into that powerful event loop and all of that. So you can make it to whatever you want, largely. Let's say you want to set up replication, you can do it. You want to copy data from one point to another, you can do that. I don't know. All of the things that typically happen with, you can even create users in it, databases in it, if you want to really go down that route. You can do
Right.
whatever you want. Imagination is.
So it's basically anything that you want to automate, you can codify it into an operator code and it will take that action.
Yes.
I think this can be the glue or the missing link which can help you convert your own data center, like Kubernetes data center based environment, into managed service. Because if you look at the database managed services, what you get is the ability to take backups, snapshots. I believe doing a restore as well, database restore. So are you also using it for all of these purposes, using automatic failover, restore, and of course the backups and all that?
Absolutely.
So what are you also using it for? Automatic restore, failover? How does that work?
Okay, so maybe we'll start off with the first one, right? The failover kind of a thing, right? And failover is a very common thing, and especially because we have our own data centers, which are much smaller in size compared to public clouds, right? Failures are all over the place. Failures will be there one way or the other, and every time any failure happens, again the operator jumps onto the thing because it is keeping a watch on all of these resources, right? And every time something is, you could say, not healthy, or none of those things, it knows what to do. It does various checks and then automatically brings back the pod up if some data copying needs to be done. It does it automatically. Restoration, for example, taking backup, for example, right? We don't keep restoring. That has to be done outside the production kind of thing. But if it's a production backup that you need to take every now and then, you need to take to confirm to the RPO, then again, you set it up in such a way that, hey, it wakes up at a certain time and then, takes the backup, uploads it to your S3 kind of a cloud storage. And then, again, keeps doing that all of the time at a Kubernetes level, the cluster level, it could be doing that.
I think this can be a really game changer because if, have the nightmares from my days of managing databases, especially Postgres at a few terabyte scale. So I can imagine when we talk about petabyte scales, it's a different ball game altogether. So when you pick an operator, a question I have is how do you decide which operator to use and whether to use the one which is already available at Artifacts repository, or should you go and write your own operator?
Great question. And again, I think this one is sort of like choosing your own databases also, right? Like, why this database versus the other database. When we started, at least we did not have too many operators out there. It was sort of still evolving. Today, probably you have an operator for most of the popular databases out there. Each operator comes with its nuances, right? And you'll need to figure out, you need to do extensive testing and, figure out whether that actually works for you or not. For your business, if that's sort of working out for not, you need to look at common patterns that are expected, what kind of things people expect in your managed service. And if the operator is able to provide some of that, it could even be things like, does it support a certain kind of disk out there, or what kind of availability it guarantees, what kind of failures it is tolerant against. Various things need to be evaluated before you take that step of saying, hey, this operator sort of works. And you can, of course, customize it as well if it's open source, right, to suit your own preferences.
And what does it take to customize an operator? So how do you go about doing that? I mean, have you picked up an operator from the open source, or did you go the way of customizing or writing your own?
Yeah. So we evaluated the operators, whatever they were available. Right? For MySQL, at least I probably say at that time, there were a couple of operators available. We evaluated them, and then we felt that it was not fitting our use case. And then we had a couple of options again. Right? We could just extend it from the operator SDK framework. So there's something called an operator framework, and that is written in Golang. And my team largely works on Golang here. And we felt that writing it from scratch and sort of putting in a lot of the knowledge of what we had already built on virtual machine managed, right? Porting that into Kubernetes was was something that would work out better for us rather than taking something from, which is probably half big, half kind of written, and then taking it to something that actually works for us. We felt, writing it from scratch actually works better for us. So that's the route we took for MySQL and HBase as well.
Right. So some operators you picked up like TidyB, and some
Yeah.
operators MySQL and HBase, you went out the way of writing it and customizing it yourself. Now, continuing on that same databases on Kubernetes, what kind of storage have you considered and what has worked well for you? Because when we talk about storage, if you go for network storage, typically there's a performance hit versus using a local storage. We are talking about how do we scale and take care of high availability. So how do you go about creating a balance there? And what kind of storage would you use if you have to, in wider audience, if they want to use a storage or pick a storage for running a database on Kubernetes, what would be your suggestion or take on that?
Great question. So databases, okay, there are typically two kinds of storages, right? One is basically your locally attached storage, which is there on the same node where your rest of your compute and all is. So when we talk about compute,
you mount it as a host path.
Yeah.
Is that what do you do?
Yeah.
Or is the local volume?
Local volume, you can say, right? So it's available there. The other kind is basically it's like just a bunch of disks, JBOD, right? So the storage is sort of outside this whole compute. So if you basically, in other words, what I'm trying to say is if a compute fails, the storage should not fail. That's a network thing. And if a compute fails in a local attached storage, both the compute and storage fail at the same time. So when we started off, we did not have a GA solution for network attached storage, and we had good amount of local attached storage. So we started off with that in Flipkart. Subsequently, in the network attached storage, you also got the EBS solution, which again has these are all available pretty common public cloud sites. So EBS solution sort of came a little bit later for us. So we are now sort of moving some of the workloads between these kind of storages. If you were to ask me what should people typically prefer? While of course it's a function of the availability of those kind of technologies also in your data center. Again, if you talk about on-prem, but if it's available, again, if the cost suits you well, you should probably choose the network attached storage compared to the local attached storage if availability is really.
for the availability
It
reason.
comes at a cost, but if your organization is okay with that cost, I would say prefer the network attached of the EBS solution.
Yes. So having a convenience of a high availability will matter if you compare it with just performance in general, right? So that would put you in advantage.
Absolutely. The whole fundamental thing here is Kubernetes has a philosophy, and that philosophy is where this whole local attached and network attached sort of makes sense. The Kubernetes philosophy is largely that any pod can go down at any time and it'll spawn up anywhere else. Kind of comes with that kind of philosophy.
Unless it's a stateful set.
Unless it's a stateful set, right?
Right.
Yeah. So that's where the thing. So if you have a local attached storage, also it would bring it down, and then it would expect it to come back somewhere else. But then who's going to copy the data? That becomes a big problem, and how long it would take to copy the data becomes a problem. So all of these challenges are typically not there if the pod which is going up and down is just a compute pod and not a storage pod.
Just attach it to storage, which is available over network anyways, in which case you don't have to worry about copying over this data and so on.
And makes life far more easier.
You mentioned about this challenge of copying over data, right? So what are the other challenges that you have seen while building the infrastructure for like at the big billion day scale and Flipkart? Anyways, the Flipkart business as usual itself is a huge scale we're talking about. So what kind of challenges that you have seen in your journey to move to, let's say, a cloud, like even FCP as the internal cloud, and then from there to the hybrid cloud and having a Kubernetes layers on top of that? So anything that we can talk about?
I think when Flipkart started, like many other companies that were sort of in that journey of maturity of cloud software, and in the absence of you could say a managed service, there's a lot of tribal knowledge in the team, right? Like not everyone knows how to work with, let's say, MySQL, even though it's a very popular database. If you really start questioning how many people know how to really administer it and sort of save you from trouble when things go south.
Especially in the world of managed services that everyone is using, a lot of things are just abstracted away and you have the know-how of the underneath what's happening.
Absolutely, right? So in Flipkart also, we were sort of in that kind of a thing where this knowledge was very localized and, very few people knew how to rebuild that thing without glitch, right? Without glitch is the thing here. Of course, you could keep trying it and figure out when a production issue happens, but then having that confidence that, yes, I really know how to do it, and documentation is updated and all of that. So that was our initial phase where we were there. But then the managed service sort of changed that because people were also changing teams, and that it is not guaranteed that the same person will be available or the local knowledge will always be available. So the managed service sort of changed all of that. It's that you don't really need to have very local, tribal knowledge, as we call it, in knowing how to create these virtual machines with MySQL, what to install, what kind of metrics to install, agents to install there, all of that you need not know. The platform takes care of it. You're just given an endpoint then. So you figure out and it will scale and will change whatever you want to do with that.
So you take the expert knowledge from the specialist and you convert it into a platform. And I believe that's where your platform engineering team kind of comes in.
Yes.
Can we talk a little bit about, because a lot of people are curious, so especially the people who are from a DevOps background, that's largely our audience is, they're very curious about what next for me. And one of the things that I talk about is, hey, you can seek, there's SRE, there's MLOps, then there's also platform engineering as a role that you can seek. So can you tell us a little bit about what does it mean to become a platform engineer or a platform practitioner? And what is it that you folks do at an organization like Flipkart?
Yep. So I'm part of the PaaS team. PaaS is basically Platform as a Service, which is part of Central Platform Group. So that's how we are sort of structured. And so the word platform is there everywhere, like if you look at it, right? And in Flipkart, we don't have a role called as a platform engineer. The org is basically all about platform engineering.
Got it.
So what kind of people actually make up this platform engineering? I would say are the regular SDEs and the SREs, the DBREs perhaps. And so it's a mixture of the traditional engineering roles. But I would definitely say that the heart of this whole platform definitely would be the DBRE. The DBREs or the SREs are the heart of this whole platform that we build. And they are the ones who sort of guide us, which way to go. If you were to say, they also play the role of a pseudo product manager.
Awesome. Can you, I'm a bit curious about the role of a DBRE then, because I've heard some organizations use the name now called as DBSRE and DBRE. Can you tell us a little bit more about who is DBRE, what kind of, what is their roles and responsibility, what do they actually do, and what should they know to get into that kind of a position or a role?
So I think the world started off with operation engineers. I think, right? That was the original.
That is how I started
like you
back in 2007
exactly
as ops.
ops, right? And slowly that whole thing started becoming DevOps because we also wanted to development and all
Yep.
of that, right? Then in that started coming out a specialization of sorts, saying, okay, DevOps is for regular things, but there are also people who know the databases really well, who don't, who are specialized in that, who know how to tune a database and all of that. Then they started being called as database administrators. So they would be the first phase who would say, oh, my query is slow. Okay, here's how you do it. Here's how you create an index. Or these are all the queries which are, taken a lock in your system and do all of that. So that was where the DBA sort of was there, and it sort of was a limited role of sort, I would say. Again, this is a term which is evolving, right? It's DBRE is basically a DBSRE. The way I was
someone who is doing SRE,
correct,
but specialized in database, and probably they started as database administrator, like DevOps engineers specialized in database administration, and now they're evolving it to do things at scale and maybe contributing to your platform engineering.
Absolutely.
Is that how it is evolving?
Absolutely. And in a way, you can sort of also, like today's discussion was going, you could say SRE is what, SRE for a stateless is what DBRE is for stateful.
I think, yeah, that makes a lot of sense. So they're like the SREs for the
stateful world.
Stateful world, right? And there are a lot of different challenges, I would assume, especially if you're talking about managing data at like petabyte scale. You can foresee a lot of challenges, right? From performance optimization, and every small optimization may result in a big impact in terms of not only performance, also cost benefits and so on. And that's where this role can become more important.
Yes. And it's also working with, so in Flipkart, for example, we are actively moving people from the self-managed stacks to, the managed platforms. It's also DBRE also plays a very important role in that. Working with these people and sort of making them understand about, why it is important to move to the, managed services and what kind of benefits come from there, what are the failover options they have, why they should do, what they should not do. And all of those things are also in the charter of the DBRE. And senior, you could say the senior DBREs who are well system, they also help us with this whole evolution of where the databases should be going. Also, they talk about the right fitment of databases within the company, for different use cases. They work very closely with application teams and guide them, saying, hey, you're probably not using the right data store for this. You should be using a different kind of data store for this. It's fitting a little better there. So that guidance is also done by DBREs.
Excellent. I'm just going to bring up a very quick diagram here. So this is something I've been actively working on as what should be the next step for DevOps is. And I'm looking at DevOps and a bit advanced positions. And let's talk about specializations, right? So one is I'm talking about SRE, where the AI ops and all of that can come in as well. Then there is a ML ops, where more about managing the infrastructure behind machine learning. And when we talk about platform engineering SRE, I think I may need to add a DBRE role as well for people who are really interested diving deeper into. Is that where you see it might make sense?
Yes, I think, yes, that makes sense there. Now, again, just to also point out, right, DBRE may not just mean...
Exactly. And that is exactly where my next thing was. So I would say, so my take on the DevOps role and the roadmap for DevOps is DevOps is a generalist. Like you become I come from a world of doctors.
MBBS, MD. I was about to say that.
MBBS, that's the DevOps.
Yeah.
And then you do like a MD, which is a specialization. Let's call it as DBRE there. And then you become a super specialist like a DM. And that's where I see DBRE evolving in the world of, especially in the world of AI. We are talking about data engineering and everything that you just mentioned about. Like earlier, it was all big data, Kafka and so on. Now we have Kafka, Fing, and there are many new technologies coming in, data lakes and those kind of things. And I see DBRE evolving into, let's say, something like what we call as a data engineer. Also, where they're dealing with streaming data, data lakes, data warehouses, of course,
vector.
Of that.
Vector,
And
vector databases, the new kid on the block.
Vector DB, that's the Gen AI stuff as well, right?
Yes.
So I think they can build the pipeline, and this can become more like a specialization area for someone who's DevOps, want to specialize in something and take it to the next level. Yeah. And does this make sense? I mean, I'm also doing a more like a research on this and again evolving this. So you start as a DevOps engineer, and how do you move in your job roles as well, right? So somewhere here I see this is the IC path, and this is more like a techno leader role. So IC role is where I see again the DBRE, and then may have a senior DBRE. Are those the kind of positions that we can say this is a is this the right way of structuring it?
So see, there are two ways of looking at it, right? Some people do think that, I mean, again, it's open to views, right? Some people do think that, okay, after a point, it doesn't really matter that you're, because every architect, let's say a regular SD architect is also expected to be, you know, like really hands-on as far as DevOps is concerned and everything else. So some people, I mean, there is an opinion out there that hey, after a point, it doesn't make sense to have that specialization. You become a generalist architect. You don't have like a DevOps architect. You're just an architect.
Got it. So you just become an architect more or less.
Yes.
And that's more like a DevOps plus everything else.
Yeah, you can say something like that. Correct. And similarly in the,
design things, because you have seen enough of systems and everything else that you are able to design things and go in like contribute in a larger way, I believe.
Absolutely. And similarly in the engineering director and all of that also, I think after a point, it's not necessary that they have to stick to DevOps. They can very well flow into regular engineering products and all of that.
That after some point you can just seek broader. So you are a generalist, you become specialist, and then as you move, then you again get a lot of breadth as well, and then just to contribute based on which company, how organization structured, and so on.
Definitely.
Awesome. So as a platform, so you mentioned, so my thinking was platform engineering is also just a role because there are certain roles, but we're talking about platform engineering as a team. So as a platform engineering as a team, how do you contribute to the organization, and what does it mean to have a platform engineering team, and what are their overall responsibility?
I think platform engineering team's main responsibility, you could say, is to largely ensure that the organization goals right in some sort, right? I mean, again, if we're talking about a platform team specialized to a company, right, is to achieve some of these things, right? The cost, the reliability has to come in, the scalability has. So we have to solve for all of these things, right? So from a company goal perspective, the platform team is sort of very vital to achieve a lot of these things, even including things like productivity. Productivity is also equally important. So
productivity of the other teams and engineers, and helping them to achieve, maybe do things in a more efficient way, or what we call as giving them the golden path to achieve their work, optimizing the.
So the way we at least look at ourselves is, so we have something called a score and context, right? So what we want to achieve at the end of the day in platform engineering is what supposed to achieve is, say there's an engineer in, let's say, supply chain, right? And for him, like his core work should be designing solutions for the supply chain. And his contextual work is sort of figuring out how the replication works and, you know, why did this query fail and all of that. So we don't want him to focus more on contextual work, but most of his focus has to be on his core work. Similarly, for us, our core is pure tech. Our contextual work might be something else. So the work that the engineers in my team do, they don't do anything with respect to e-commerce. We don't have sellers, we don't have customers, and you know, whatever SKUs, and we don't have any of that. For us, it's just largely e-commerce scale. Very abstracted out. That's the biggest advantage and the role that we sort of play in the larger Flipkart ecosystem.
Right. So it's about building tools for the customers, building platforms that the other teams and overall Flipkart, everyone in Flipkart consumes, and working on those kind of technologies. So what kind of tech that we are talking about when it comes to your team as a platform team? What technologies are you using? What programming language? I mean, are you building a lot of custom tools that work for internal customers?
No, so it would depend from, of course, product to product, but we largely use Golang here because I think it works well from a platformish construct. The kind of requirements that are typically there, managing, working closely with Kubernetes itself within Golang. So
In the world of Kubernetes, where
makes a lot of
Go is
sense.
very dominant.
Yes, right. And the tooling, working with tooling, Python also is a great example in this world. So we have products which are in Python. We have a lot of newer products which kind of need that kind of scale and the concurrency, multi-threaded, all of that. Yeah, that is starting the Golang kind of space, ability to build CLIs and all of that, right? So that is where the Golang really shines. As far as databases are concerned, I think we use whatever, in some cases we use etcd, in some cases we use Mongo, some cases MySQL. So it sort of depends, but we don't want to keep it too open also out there. We only are trying to limit ourselves to using certain databases, and of course the latest versions of those databases, so that we don't have those other problems. So yeah.
Right. So if one wants to go from or get into platform engineering role, I think they can start from as a DevOps engineer, and then they can be DBRE, contribute to platform engineering. They can be SRE. They can pick up, maybe if they have interest in writing code and they have systems knowledge, they can be is a good candidate for platform team. Is that right to say?
Yeah, absolutely. I would say that. So platform team largely, the SDs here, right? Again, if you're talking about SD versus SRE, of course, we know that, they need to have very good knowledge about infra, Kubernetes,
Absolutely.
administering. They should at least have a couple of specializations, at least one specialization they should definitely have, whether it's MySQL or whether it's Kafka, HBase, something. It would be really good if, you are able to specialize in one thing, also understand Kubernetes, how it works, have good practical first class, first class knowledge of um, uh, administering some of these things. So know the product in and out, right? So these are all things I would at least expect people to have when this thing, apart from scripting and all of that.
Right.
SDs are, I would say, largely the people who are interested in going in depth, right? Who are a little bit more nuanced than reading from database, writing to database, or writing some APIs on top. The platform engineering or the SDs part of platform engineering do far more work than that. They are also supposed to understand various failure modes. So you could say probably 35% of their work involves coding. Rest of it involves designing and understanding how things work for failure, designing for failure, writing one pagers, discussing with people, chaos testing things, and all of exploring, open source options out there, looking at, trade-offs between various decisions. So that I would put it that way. And they're also the product managers of sort, right? Because they know those products really well. So they're also expected to guide it into. So yeah,
They have a deep knowledge of
very deep
the
knowledge.
product. Right.
Yes.
You mentioned about resilience testing and chaos testing. So is that also part of the platform, what you do as platform engineering?
Yes. So chaos testing is something that is central to a lot of these platforms, and we do regular testing as well of some of
I
these
would
things.
I would imagine, especially leading towards big billion days, you
Yes.
must test your systems really
Oh
to
yes.
make sure they're strong enough
Yeah.
and resilient enough to
Yes.
take any kind of a load, right? So
Absolutely.
can you give us some brief about, I mean, any like insights into that, like how you go about chaos testing? Do you build your own tools, or do you use any specific open source? There are platforms available as well, like chaos, right, including Chaos Monkey and all that. So how do you go about chaos engineering?
So largely, I think we use Chaos Monkey kind of system, like outside in. Of course, there are different teams for whom if this Chaos Monkey doesn't work exactly as expected, they sort of build some of local solutions wherever possible. So it's a mix, I would say, of what is out there in the open source as well as some of the things that we have built. So one part, of course, the chaos testing where you and it doesn't really talk about scale. It largely talks about random failures at various points
Right.
in that Kubernetes or wherever, and to see whether we are able to detect some of these failures. The most tricky ones, of course, would be the network related failures, and where two networks are sort of isolated and all of that. So apart from that, I mean, regular failures whichever they happen, these tools are able to catch it, and the platform team's core work is to ensure that all of these scenarios are captured by the operator and able to recover from that in a reasonable time. So that's the objective. The other part of the thing is the scale part of it. So each team which comes before the big billion day typically also does NFR for their own services, and the platform team provides them that kind of hardware for them to test out in case they feel
Right. Awesome. And just we are moving towards the end of our, this expert talk here. So I'm just curious to know how you landed up with platform engineering. What is your personal journey briefly, and what makes you interested in the work that you do? This is where we actually lost some footage from the conversation with Vaidi. That's where we talked about his journey from SDE to platform engineering, the kind of work that he enjoys, and a few other things that we spoke about. So my apologies to Vaidi and to you, the audience, who's been watching this with so much of interest and staying tuned for. I really thank you for staying tuned so far. And I'm just gonna play the rest of the part where you'll most likely see my reaction to what he was talking about. But that's all we have for this episode. I hope you enjoyed it so far and you learned from the conversation with Vaidi. We'll probably bring him again to talk about his career, his story, and maybe some other interesting topic that would also interest you there, right? So that's all for this episode. I apologize for losing that footage during the editing process, and let's conclude this conversation. Do let us know what you liked about it, and do let us also know what is it that you would like us to bring on this show, this podcast. So thank you, and stay tuned. I think Hadoop originated at Yahoo, and then the whole concept of big data. Now the big data has no more become a big data. Now just we will drop the big name and we are calling it as a data engineering. Yeah. Sure. Final question to you. Managing people or working with just tech hands-on? What do you enjoy most? Which one would you love? That's a smart answer. Thank you so much, Vaidi, for your insights. We would love to dive into some of these topics probably some other day, but it's been wonderful talking to you. And thank you for all your insights and answering these. Thank you and all the best. Bye-bye.